Hello, calculus fans. Let's say we have a projectile which is fired with a muzzle speed of 200 meters per second. So that's the speed at which it leaves the firing mechanism at an angle of 32 degrees from the ground. The firing position is going to be 15 meters above the ground, and we want to know where does the projectile hit the ground and with what speed. Let's go ahead and round all of our answers to 2 decimal places. So we'll go ahead and place the origin at ground level, and then the initial position of the projectile is at 0.15. So this means we need to adjust our parametric equations that we came up with in the previous computations by adding 15 to the expression for y. So that moves everything up 15 units. All right, so our initial speed is 200 meters per second. Our launch angle is 32 degrees, and the acceleration due to gravity will use 9.8 meters per second squared. All right, so we've got x is equal to 200 cosine 32 degrees t, y is equal to 15 plus 200 sine 32 degrees t minus 1/2 times 9.8 t squared. So the main difference now is this 15 that we have to add to the y. Now we know that our projectile will hit the ground when y is equal to 0, so we set y equal to 0 and solve for t. Alright, so we take that equation that we had before, we've got y equals 0, that gives us a quadratic equation, so in order to solve for t, we'll just plug everything into the quadratic formula. Wow, what a mess. Now we've got 2 solutions here. You can tell that because of the plus or minus that's in here. So if we work out these values, we'll get t equals negative 0.14 and t is 21.77. And those are approximate, rounded to 2 decimal places. These are times. We're solving for t here. The negative solution is physically nonsense. We can't really go back in time. So we want t equals 21.77. Now physically what that 21.77 represents is how much time it takes for the projectile to come back and hit the ground. So let's plug that t value into the expression for x and we'll get the horizontal distance. So the distance that this thing travels is 200 times cosine 32 degrees times 21.77, and so we get approximately 3,692 meters. Finally, we need the velocity. We need that because we want to know the impact speed. So the velocity is the derivative of the position function, and so we get 200 cosine 32 degrees I plus 200 sine 32 degrees minus 9.8 tj. Notice that I keep everything in exact value until we get to the final answer. You should always do this as a general rule. Keep things as exact value, and only in the very last step should you perform some kind of an approximation. Alright, let's measure the speed at impact. I'll plug in the 21.77 into here. And then we need the speed, so we need the length of the velocity vector. And if we work that out, we get just about 200.7 meters per second. Remember, the muzzle velocity was 200 meters per second, so it's going a little bit faster when it hits the ground. Now we're doing all of this, of course, assuming no air resistance. Let's summarize our results. It takes 21.77 seconds for the projectile to hit the ground. It does so 3,692.4 meters away, and it will impact at a speed of 200.7 meters per second. Make sure that we've got a distinction between speed and velocity. Okay, that's all for now.